Welcome back to the last video of Section 2.3. As always, this is Mr. Spinks, and we're talking about sets again, guys. Now, pay attention this time. Here's a formula coming up that we often mess up because we don't remember it and don't focus on it. Let's look at it. It's real simple. It says the number of elements in the union of A and B is equal to the number of elements in A plus the number of elements in B minus the number of elements in A intersection in B. Remember, A union B is element or are all the elements that are in either or. So this is either or going on right here. Whereas when you look at the other side, let's write that out. Either or. On this one, intersection, it must be in both sets. Real important that you can understand that and that you can identify that. Let's move on to the next example here. As we look, it says the result of a survey showed 40 people like baseball, 55 people like football, and 20 like both. First thing we're going to do is to understand what the sets we're dealing with are representing. We're talking about two things, baseball and football. So I'm going to make A the baseball, and I'm going to make B the football. Next thing I would do if I were you, I would definitely do this. Write out your actual formula here and fill in for each one. Now the first thing I'm going to look at is the question, how many like baseball or football? That is either or. How many like either or? Well, either or was the union. That's what I'm going to find out. That's what I'm going to figure out. That's what X is in this case. Next up, I'm going to find out the number of elements in A. Well, A is baseball, number of people that like baseball. It says 40 people like baseball. So that's the N of A going on right there. Next up, I'm going to find out the N of B. How many people liked B? Well, B was football. How many people like football? It says 55 people liked football. So that means N of B is 55. Hopefully you're seeing how simple this is, guys, if you actually follow it. But I'll tell you, it was missed heavily last year, heavily, because people didn't know it and weren't focusing. Please be paying attention. Finally, number of elements of A intersected in B. A intersected is B are those elements in both sets. And it says right here that 20 people liked both baseball and football. So A intersected with B is 20. Now I do simple math. Turns out 40 plus 55 is 95, and 95 minus 20, well, X in this case is going to equal 75. Since we always label, we're talking about people in this case. Real easy stuff, guys, not hard. Once again, make sure you're focusing. Got one more example for you to make sure you're good with this. It says at a local school, 17 students took either science or math. 53 took science, and 53 took math and science, 41 took science. They want to know how many took math. Well, we're talking about two things again, math and science. I'll make A the math. It doesn't really matter which one's which, but it is important that you define them and write it out for me. This must be there on your paper, or I cannot mark you right. B is going to be the science. Now, A union B, well, those are in either or, okay? So it says 17 students took either science or math. That is the union going on right there. Moving on. It says 58 took science and math. That's both. That's the intersection right there. So we will fill 58 in for the intersection. Next move. 41 took science. Well, science is B, so number of people that took science is 41. Finally, as you look here at my example, they're asking how many took only math. Well, the people that took only math are the A people. That's what I'm looking for. That's my variable. That's where the X goes. From here, we are solving a linear equation. The first thing I'm going to do in this case is going to do 41 minus 58. Well, it turns out 41 minus 58 is negative 17. So 17 equals X plus negative 17 or minus 17. From here, to solve for X, I'm going to get rid of the minus by adding 17. when I add 17 to the other side. 17 plus 17, doing a little quick math, is 34. That means x equals 34, and we always label this is 34 students. Again, not hard formula. Make sure you got it, guys. Very, very important. Last thing we've got here, we've got to talk about the difference of two sets. So, in talking about the difference of two sets, the difference of two sets is defined as the set, get rid of caps, the set of all elements that belong to A but not to B. And when we're talking about this, this has to be the difference of two sets A and B. Okay? Now this is denoted as A minus B, just right here. A minus B is what we're talking about. And we'll give you some examples to help you to understand this. Once again, if it's the difference of A and B, they've got to be in A but not in B. So we look. Once again, we've got a universal set. A's got B, C, and G. B's got A, C, E, and H. C's got A, D, E, F, and G, and H. Wow, the fun. Now, once again, I look down to start, and I see the primes, A prime, B prime, and C prime. So I'm going to define those first. As I look, we're talking here about A prime. Well, if A has B, C, and G, A prime, in this case, has all the elements that are in the universal set, A, D, E, F, and H, that are not in A. B is A, C, E, and H. I will define B prime to make my life easier later. B prime is B, D, F, and G. Finally, C prime, well, if C is A, D, E, F, G, and H, C prime in this case is just B and C. I will use those later on. All right, let's start off with A minus B. Those that are elements of A that are not in B. Well, A's got B, C, and G. Looking down here, what are in A that are not in B? Well, I don't see B down there. That's one of them. I do see C, but I don't see G. So B and G would be in A minus B. Let's reverse it. Let's do B minus A. What's in B that's not in A? We'll start in B. Is A in A? No, it's not. It's one of them. Is C in A? Yes, it is. Is E in A? No, it's not. And is H in A? Yes, it is. Moving down to A minus C prime. Well, we've got A, it's B, C, and G. C prime is B and C. So what's in A that's not in C prime? I just see one of them, just G. Moving on, we're going to do C minus B prime. C minus B prime is those that are in C and not in B prime. Well, I look, I see A, it's not in B prime. D is in B prime, that doesn't count. E is not. F is, doesn't count. G is, but H is not. Whoop. Pretty simple stuff, guys. That's our idea on the minuses going on between sets.